spheres. Okay, so we're talking about the surface area and the volume of spheres today. Remember, a sphere is like a ball. Okay, a sphere is just a ball. Technically, the definition in math says a sphere is a set of all points in space equidistant. We've used this word before. What does it mean? Yep. Distance. Yep. So equidistant from a given point called the center. So it's really close to the definition of a circle, because a circle said it's equidistant from the center as well. But with a circle, it's flat. We're talking about in a plane. In this case, they're talking about in space. So in space means it's three-dimensional. In a plane means it's flat. But they really have the same definition. And just like in a circle, we have a radius. So a radius is a segment that has one endpoint on the sphere. Should be at the center. At the center. And the other is on the edge of the sphere. Just like with a circle, we measure from the middle to the edge. And a diameter, like with a circle, segment passes through the center, and both endpoints are on the edge of the sphere. Just like a circle. Okay. And we're finished on the database space over here. That's fun. Alright. So, if we have a tennis ball or a baseball or something like that, if you look at the stitching, it goes around this way, it comes around like that, and if I was going to cut it at the stitching, how many pieces would I end up with? End up with 2 pieces. If we take those pieces and we lay them flat, they're going to look kind of like this, right?
There's none of our balls. Those things are balls.
They look like little peanuts.
We'll bring some in sometime.
Before you leave.
We'll rock it. Anyway. Okay, so if we take the cover off of a baseball or off of a tennis ball and lay it flat, like 2 pieces, and the 2 pieces look something like this. What do they kind of look like?
Peanuts.
Okay, they kind of look like peanuts. What else do they look like?
And swimming pools.
Swimming pools. Okay, thinking like figures, geometric figures, where they look like circles. Okay, they look kind of like circles put together. About how many circles do we have?
2. That was the answer. Circles put together.
4.
Yeah. 4.
We gotta get more creative than that.
Yeah.
Like blue eyes.
Okay, so they kind of look like a circle, right? Okay? That's way too creative. Alright, so if we find the area of one of the circles and we take it times 4, we're going to get the area of all the pieces. I know it doesn't look like it. I know it looks like there's extra pieces here, but it's really not. Because these are kind of overlapping here, so if you take the area that's overlapping and spread it kind of here and here, we're actually going to get 4 circles. The area of 4 circles. Okay? So the surface area of a sphere, like the covering of a baseball or tennis ball, is actually 4 times pi r squared. 4 circles. 4 circles are what's needed to cover the surface of the sphere. Okay, so this is basically what I just said. Example 1 says, find the surface area of the sphere and leave your answers in terms of pi. Alright, so all we need to know to find surface area is the radius of the sphere. What's the radius of this? 4. So you're just going to go 4 times pi 4 squared. So then of course go to 16. What's 16 times 4? 64. We'll just have 64 pi. And then we do label, and we're talking surface area. So is it cubed or is it squared? Squared. It's going to be square. The surface area is flat. Surface area is just a covering. Okay? Pretty easy peasy. Look at a B. Okay, they give us what?
The radius.
Give us the radius. All you do is go in the formula. 4 times pi, 9 squared in this case. 9 squared is 81. What's 81 times 4?
324.
Don't forget that it is squared, not cubed. Squared because we're talking surface area.
I see Chris Paul.
Anyway, okay, do you need to do the last one? I think you guys
No.
got it,
I
right?
got it.
On the back, talking about the volume. The volume is the stuff that goes up on the inside, right? Volume of a sphere is 4/3 times pi r cubed, not squared, but cubed. Yes, yes. Okay, gonna try and kind of explain where this formula comes from. Okay, I want you to visualize in your head a soccer ball. Okay, soccer ball. Okay, so on a soccer ball, what is it covered with? What shape?
Hexagon?
Hexagon.
It's black or pentagons. That's what it's
Yeah.
Oh, they're hexagons.
I think they're all hexagons. Okay?
There's a letter.
Yes.
Let's go switch to one.
Okay? It doesn't really matter exactly what they are. They're geometric shapes, right?
Yes.
Okay? If you think about all of those hexagons, or what they are, if you think about all of them as a base of a pyramid, and all the pyramids come together, so that the points of the pyramid, the vertices of the pyramids, all come together to the center of that soccer ball. Kind of understand what I'm talking about? Okay, so if we just take a whole bunch of pyramids, put them together so that all of the centers, or all of the vertices come together in the center of the soccer ball, and all the bases are on the outside to make the soccer ball. Okay, that's when they kind of come up with this formula, because it's going to take 4 circles, like with the surface area, but remember with a pyramid it takes 1/3 times, right? So that's where the 3 comes from. And then the pi r cubed. Cube is because we're talking in 3 dimensions, because we're talking about volume. That's kind of where that formula comes from. And there is a much longer proof of how it comes to be, but that's the general idea. Does this kind of make sense?
Yes.
If 3-dimensional is 3D and 2D is flat, what is 1D?
Seriously, I almost
I know.
1D. Okay.
No.
Well, 1D would be like a point. Remember way back at the beginning of the year when we talked about a point is a location in space that has no area, no dimension at all. A dot, if you want.
We're all dots.
1D is non-existent. Uh-huh.
Uh-huh.
All right. Let's look at example 2. Says that we're supposed to run along the sphere, and again, leave our terms in pi. So just filling out our formula again. So we got 4/3 times pi. What's our radius? And we're going to take 4 cubed, not squared. So the order of operations, we're going to do exponents first. What's 4 cubed?
64.
So if your calculator does not give fractions, you can take 64 times 4 and then divide by 3. That would be a way to figure this out.
It comes out as a fraction.
Does this one as a fraction? Okay.
Yeah, I got 85.33333.
80
Do you want to?
1/3, 85 1/3.
Right. We want to keep it as a fraction because remember, in terms of pi, we have to be exact. We cannot round in terms of pi. In terms of pi, is exact. And there should be meters. Is it cubed or is it squared?
Cube.
It is cubed because we're talking volume.
Can we leave it in? No, I can't remember which one.
256/3.
Yeah, can we leave it in that form?
Oh, what is that from?
I don't remember.
Improper. Yes, you could leave it as improper. Usually we put it as a mixed
How
number.
do you get it so it would be like that?
You're going to take 85 times 3 plus 1. That would be your.
Okay, so we get it from 256. Oh.
Alright, for B, same thing, just fill out your formula. In this case, our radius is 6. What's 6 cubed?
216.
So 216 times 4/3.
Is 288.
Really? That's it?
Yep.
Seems really small, but I'll take your word for
I
it.
know, where I was like, oh.
Okay, then for last final examples here. It says the volume of a sphere is about 5,000 meters cubed. What is the surface area? Okay, so they're talking about the same sphere. Okay, they're giving you the volume of the sphere, they want you to find the surface area. Let's say, between the volume formula and the surface area formula, what do they share in common? What's the existing? Radius and pi. Okay, so in order to go from the volume to the surface area, we need to figure out what the radius is, correct? Okay, because once we find radius from the volume, we can plug it in to find the surface area. So our first goal in these types of problems is to find the radius. We're going to do that by using the volume. Because the volume formula says 4/3 times pi r cubed, right? Okay, so they give us the volume is this 5,000. So that's what I'm going to put in for B. We are solving for r. Okay, think of r as like an x. What do we have to get rid of?
The 3 and the 4/3.
4/3 and the
Pi.
pi is what we need to get rid of first. How do we move it to the other side? Oh, we did not multiply, but divide. Because it's already multiplying, we went to the opposite, so we're going to divide. So I'm going to take 5,000 divided by 4/3 pi equals radius cubed. Okay, don't plug this in calculator quite yet. Okay, now, I know you did this way back in Algebra 1. Let's just pretend I'm making something of those, don't write this down. Let's pretend I did something like this. How do you solve for x? You take the square root, right? Okay? Really, there's an understood 2 in the corner of this box, okay? It's like when you write x, it's an understood 1, it's not always written there. When you write the square root of a box, it's an understood 2 in the corner, it's not always written there. Okay? So now that we have a 3, instead of taking a square root, we are going to take a third root. Okay? On your calculator, I want you to look. There's usually a button that looks like this. Or,
That's
you have a button that
I always click that one by accident.
okay, I want you to look at your calculator. So you're either going to find one with a 3 in the corner or with an X and find it. If you need help, let me know.
I can't find you.
Alright.
It's 0.
No.
Actually, we're.
Okay. Alright, what I want you to do is I want you to find the third root of 8 for me on your calculator. Just make sure you're putting stuff in correctly.
Wait, what?
The third root of 8. Find the third root of 8.
It's X. 2. No, wait. Got it.
So find the third root of 8.
Double I.
Oh, okay.
Yeah.
What is it? How did you do that? It is right. It is? Yeah. It's 2. 2 is
Alright, you should come up with 2 because the third root of 8 should be 2. You come up with 2, you type it in wrong.
Third root.
Third root. Alright, so going back up here, we are going to take the third root of this whole long, big, yucky thing, right? Okay? So, when you type in the third word of all this stuff, you have to be very, 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 very careful on how you type it in. Because yes, it will make a difference if you don't type it in right, you're going to get the wrong answer. Okay? So what I would do is I would put this whole thing in parentheses, because once you get the third word of the whole thing, and I would also put the denominator in parentheses to make sure you are dividing by that whole thing out the bottom.
Can we divide first and then just put the actual number, like 5,000 divided by 2, that's pi? Do that and then.
No, because this is going to be a big one, that's all I need to do rounding, and then I'm going to do that.
You know you do it on my calculator.
Yes. 2
We
seconds.
have to figure it out. It's a big long.
Okay, this is what you should come up with. If you do it right, 10.607.
Oh, nice.
Let me double check myself.
No, that's right.
Yep, so you should come up with, if you do it right.
Help me figure it out.
Type number, and then you're just going to put in the fraction form. 5,000 divided by parentheses. 4 divided by 3.
Okay, I got
Close parentheses. Okay, this is around a whole lot, right? Equals. And then I'm going to go third.
Yeah.
This? Okay. Anybody else having troubles?
I got it, yeah.
So it's yours, you just have to
And that's just the radius, now we have to find the circle. That part's easy.
But I have like a better one,
So
so
what
I
you're
can
going
have
to do
this.
is
The one I
So let's just do like the first square.
I just like this one because I can use it.
And you have games on it.
There you go.
That's cool. Oops, you know there's some calculators that like, if there's some in the same room that like eject it, you get like chat. They go to things that
You know what the new cheat thing is in new phones, you can actually write a formula on it and it'll figure it out. I'm like, that's so cheap. That would be so unfair. No.
It's not serious.
Top of the
Like,
fraction.
I got some apples.
You said,
Yeah, we got my friend.
what's 2 times 4?
Like, we were like saying hi and all the complicated stuff.
Siri is very fun.
Except
No, whatever number that would be is if you got that like.
I actually did, like,
You have all your.
No.
Tell her to keep
We have an iPhone here in between.
I didn't have to be so big,
Like, she said I had like chalk
Oh, wait.
and English like when I was that's what I used. And I would actually call her. You always were a writer.
Okay, anybody else need trouble with the typing it in? Okay. Okay, we need to finish this problem real quick here. So, we found the radius of the sphere. They want to know what the surface area is. What are we going to do now? Okay? And you want to keep all of these decimal places in your calculator. Do not clear it and then try and type it in again, because on your calculator, even though it doesn't show you, it is actually taking this number off further. So if you clear it and then type in this, you are rounding it. Does this make sense? Okay, so you want to keep all these decimal places on your calculator. If you have to clear it, then you have to clear it. You should. Because how do you find surface area? What are we going to do?
4 times pi times radius squared.
Okay, so we're taking this whole long thing on your calculator. Is it the square button? Your caret key squared. What number you doing there?
We're doing times and equals.
Okay, that whole big long decimal. So square that, then take it times 4, then take it times 5. Then you calculate.
You want to round
In
it?
this case, it's fine. Sometimes it will round it just a little bit different. Yeah.
Mine's not working. What's it?
You broke the calculator.
Oh, snap, what just happened? Good, so I have to learn.
Chris, is it fire or cereals?
She's gone today, we don't pay her.
Score.
Then go carrot.
$30.
Wait, yeah.
Oh, okay, gotcha.
It would be funny.
There's that becomes my idea. All right, what do you guys come up with?
I got it.
Came up with 1,414. 0.04, blah, blah, blah.
Okay, and with these, we'll probably just want to round, unless directions say otherwise. On these types, since this is all kind of rounded itself anyway, and we're not going to be super exact, on these usually want to round to the nearest whole number. So we'll just leave it this way. Alright, this is exactly like what we just did. Do you want to go through this one?
No.
You got the idea?
Yeah.
Can you kind of go through it so I can do it and see if I'm doing it right on my own?
Yeah, will you just give us the answer, because I want to see if I did it right. I'll just give you the answer.
Here's the answer, guys.
Like you just ran with it to the nearest what?
Nearest whole.
What? I got it right then.
Oh, okay, everybody good?